Hello students, welcome back to a new series of mathematics program for grade 9. In this video, we are going to talk about the chapter on vectors and translation. Well friends, today's session is the first part regarding this chapter. So let's start. In this program, you are going to learn what is meant by a vector quantity, how to distinguish between scalar and vector quantities, and finally, how to express a vector in column form. Students, a vector is a quantity having both magnitude and direction. It can be represented geometrically by a directed line segment as shown below, where the length of the directed line segment is called magnitude and the arrowhead indicates direction of the vector. Students, in general, magnitude refers to size or quantity. Well, an example of vectors in real life can be illustrated by the displacement involved in reaching town A or in reaching town B from a certain road junction. Here, the displacement to town A involves traveling 22 kilometers due east, while the displacement to town B involves traveling 13.5 kilometers due west. Students, displacement is a vector quantity. Now, let's talk about scalar and vector quantities. A scalar is a quantity having only magnitude, which implies a scalar quantity needs no direction for its complete description. Some examples of scalar quantities include length. For instance, the length of a pencil is 15 centimeters. Mass. Example, Mrs. Kiran bought 2 kilograms of potatoes. Time. Here, schools starts at 8 a.m. Students, are speed and velocity same quantities? Remember, speed implies the rate at which someone or something is able to move or operate. For example, the Bugatti has a top speed of 407 kilometers per hour. Observe, speed is expressed completely by its magnitude only. Therefore, speed is a scalar quantity. Now, velocity means speed in a given direction, which can be illustrated by the movement of a car at a certain speed in a given direction. Therefore, velocity is a vector quantity. Thus, speed and velocity are not same quantities. Students, this example illustrates how to distinguish between scalar and vector quantities. Let's look at part A. The distance between any two light poles is 15 meters. Students, distance implies difference between two fixed points. Therefore, distance is completely described by its size only. Hence, distance is a scalar quantity. Part B. The volume of the following water tank. Here, the volume of this cubical water tank is equal to 1 meter times 1 meter times 1 meter. That is length times width times height, leading to 1 meter cube. Students, observe. There is no direction needed in calculation of volume. Hence, volume is a scalar quantity. Part C. In a game, Tom has to search for a treasure hidden at Q which is 30 walking steps away due east of P. Here, the displacement of Tom from P to Q involves walking 30 steps due east. Thus, displacement of Tom is a vector quantity. Part D. The change in temperature. Friends, temperature is a scalar quantity. For example, the temperature of this room is 25 degrees Celsius. Now, change in temperature can either be an increase or a decrease, which involves direction. Therefore, change in temperature is a vector quantity. Students, now you are going to learn about representation of a vector. Consider a directed line segment P with starting point A and end point B. This vector can be represented as, well, if we take into account the starting point A and the end point B, we can write it as AB with an arrow on top indicating the direction of the vector. Or we can simply use the label of this directed line segment, which is P. Students, let's take a look at representation of a vector in column form. When the vector AB is drawn on a grid, it is represented as a column vector with components H and K, where H represents the horizontal movement and K represents the vertical movement. Friends, H is also referred to as the horizontal component and K is also referred to as the vertical component. Now, if the vector AB is drawn on a grid, we obtain a directed line segment with starting point A and end point B. To express the vector AB in column form, first we consider the horizontal movement from the starting point A. Suppose here it is h units, implying the horizontal component of the vector AB is h. Now we look at the vertical movement. Suppose it is k units. Therefore, the vertical component is k. Hence, we've represented the vector AB in column form. Students, whenever you have to express a vector in column form, remember we consider the horizontal movement first, then we look at the vertical movement. Next, we are going to talk about horizontal and vertical movements. Friends, horizontal movement can either be to the right or to the left. If we move h units to the right, then h is positive, while if we move h units to the left, then h is negative. Now, vertical movement can either be upwards or downwards. If we move k units upwards, then k is positive. On the other hand, if we move k units downwards, then k is negative. Students, now you're going to learn about representing a vector in column form through the example 2. Here, write the following vectors in column form with components h and k. In part A, we have to express the vector AB in column form, as indicated by the directed line segment. Remember, first consider the horizontal movement from the starting point A, which is 3 units to the right, implying the horizontal component is 3. Next, we look at the vertical movement. Here it is 4 units upwards. Thus, the vertical component is 4. In part B, we have to express the vector EF in column form by first considering the horizontal movement from the starting point E, which is 2 units to the left. Students, what is the horizontal component here? Well done, -2. Next, we look at the vertical movement, which is 4 units upwards. Thus, the vertical component is 4. In part C, we have to express the vector A in column form by first considering the horizontal movement from the starting point of the directed line segment, which is 6 units to the left. By now, you already know that the horizontal component is -6. Now, we look at the vertical movement, which is 2 units downwards, implying the vertical component is -2. In part D, we have to express the vector P in column form. Students, what do you notice about the horizontal movement? Very good. There is no horizontal movement. That is, the horizontal component is 0. Now we look at the vertical movement, which is 5 units upwards. Thus, the vertical component is 5. Friends, now it's time to take some exercises for practice, which will definitely help you to understand better today's lesson. Take note, question number 1. Question number 2. To summarize, in this program you have learned about a vector quantity, how to distinguish between scalar and vector quantities, and finally, how to express a vector in column form. Friends, here are some links which will provide you with additional information regarding today's lesson, so take note. Students, this video on vectors and translation ends here. Remember that today you have learned about vectors, scalars, and how to represent a vector in column form. In the next video, we are going to talk about magnitude of a vector, equal and negative vectors. So friends, till we meet again, it's a goodbye and see you soon.